Hello friends, we are continuing our third unit, the topic reading a theodolite. How we have to read. It is more important while using the instrument. In this you are seeing a circular graduation which contains the degree 0, 10, 30, 20, 30, 40, 50. It's clockwisely, right? So up to 360 degree. Here you can have 0 to 360 and 0 to 180 and again 0 to 180, right? This is the way of representation of the graduation. Where it will be, this graduation circle will be in the horizontal circle and the vertical circle. In both the circle, the graduation for the degree will be like this, right? So 0 to 90, 0 to 90, 0 to 90, it will be helpful for the vertical angle. For horizontal angle 0 to 360 degree, it is helpful. And you are here seeing there is a gap for 0 to 10 degree. So in between there are 1 degree, 2 degree, 3 degree, 4 degree, 5 degree, 6, 7, 8, 9, right? The remaining degrees are there. How it get enlarged, right? That is the next thing. When you zoom it, you are able to see this in the instrument very clearly through the lens. The graduation will be like this. This is the one main division, two small division, next main division. Say for example, here they have given us 150, next main division 151, 152, 153, 54, 55, 56, 57, 58, 59, 160. So this 10 degree gap here it is shown, right? So it will be like this only. Then what is the in between two division? So if it is the 151 degree and it is 152 degree, the gap is 1 degree gap. Then what will be the division? There are 3 divisions, right? So 1 degree means 60 minutes. 60 minutes, 3 division is what? 60 by 3, it is 20. So each small division in the main scale is 20 minutes. So 151 degree 20 minutes, 151 degree 40 minutes, 151 degree 60 minutes we can say, then it will become 152 degree, right? Then where is the seconds? For that only we need the vernier scale. The vernier scale will be inside the main scale. So this is the main scale. Inside the portion there will be a vernier scale A, and here there will be another vernier scale B. So A, B, there will be 2 scales for the horizontal circle. Similarly for the vertical circle there will be, since it is in the vertical direction, the C scale and D scale will be in this C scale, D scale will be here, vernier scale. But how to read the vernier scale along with the main scale? For that only this diagram you try to understand. This is the main scale reading. You are able to see here that 10 division 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 division is there. So 0 to 10, the same 150 to 160, 10 division. The intermediates are 1 degree and the small division is, again I have explained here, is 20 minutes. Here there is a vernier scale. It is also having the same type of pattern. Say 1 main division, 2 small division, next main division. It is coming this way or this way, both the way, right? So see here also some numbers are given, 0, 1, 2, 3 up to 20 only it is available. From that you have to remember each 20 minutes in the main scale is splitted into 20 divisions, as that here each 1 minute. So if it is 0 minute, here it is 1 minute, 2 minute, 3 minute, 4 minute, right? It is keep on going. So the division here is what? 0 to 1 minute. 1 minute has 60 seconds already, you know. So again here also there is 2 small division which split into 3 divisions. So 60 minute can be divided by 3 means 20 seconds. Each small division in the vernier scale is 20 seconds. So degree minutes is taken from the main scale, and minutes and seconds we have to take from the vernier scale. Both the minutes has to be added. If it crosses 60 minutes, it has to be given to the degree. Say for example, if it is 140 degree 40 minutes, and here you are getting 20 minutes again. So 140 degree 40 plus 20, it is 60 minutes. So 141 degree, right? So this way you have to consider. So this is the vernier scale graduation in all the theodolite. So the least count of the theodolite will be 20 seconds, right? So the coincidence has, how to take the coincidence, I am going to explain with the next slide. So the theodolite is represented by the diameter of this graduation circle. 20 centimeter theodolite, 10 centimeter theodolite. If the circle diameter is keep on increasing, the accuracy level and the graduation also will be increasing. If the increasing, the least count become 20 seconds will may increase to 10 seconds or even 5 seconds or even 1 second, right? So if the circle get diameter get increased, the accuracy. So when the accuracy is needed, that type of theodolite will be used, right? So this is the zoom of the main and the vernier scale. Say the top portion is the vernier scale and the bottom is the horizontal main scale, right? So if it is the 0 of the vernier, it's keep on going it up to 20, right? So if the 0 of the vernier crosses a particular degree and minutes, you have to consider. So for example, in this diagram, the 0 of the vernier crosses 10 and the next division is 20 minutes. So 10 degree 20 minutes is confirmed. But is there any extra minutes and seconds is there? That we have to confirm. So how to confirm it? The division lines in the vernier and the main scale, somewhere else it exactly get coincide. Where you see here the line, it may look like exactly straight. You may see somewhere else here also, but any one will be exactly straight. That you have to confirm by zooming the lens while seeing the reading, right? So now we consider, say this is the exact straight line. If we consider this is, see already we are having 10 degree 20 minutes plus how many vernier main division up to here? 5, 6, 7, 8th one is get coincident exactly. So 8 minutes is additional. So you have to add 10 degree 20 plus 8, 28 minutes, 0 seconds. If any seconds lines are get coincide, say example, if this one is exactly straight, so it is 28 degree 20 seconds, right? 10 degree 28 minutes 20 seconds. This is how you have to read the reading in the theodolite, right? If you are not understand, please pause and rewind and listen back so that you can able to understand. This has to be used while using the instrument, right? Based on this, the classification of theodolites are transit theodolite, non-transit theodolite, vernier theodolite, micrometer theodolite, right? What are they? Transit theodolite means when its telescope can be transited, that is revolved through a complete revolution about its horizontal axis in the vertical plane, right? But the non-transit is the telescope cannot be transited, they are inferior in utility. So nowadays non-transit theodolite are obsolete, right? So predominantly transit theodolite is used. Next is vernier theodolite. For reading the graduated circles, if verniers are used, the theodolite is called the vernier theodolite. In the last portion, I have explained how to read the verniers. So predominantly we use the vernier theodolite only. Whereas if a micrometer is provided to read the graduated circle, the same is called the micrometer. Predominantly we use vernier type theodolite are commonly used, since there only we can read the exact reading, right? And this theodolite should be transit also. So transit vernier theodolite is the most predominant type used in the field, right? So already I have said the size of the theodolite is designated by the diameter of the graduated circle on the lower plate. The common sizes are 8 cm to 12 cm, while 14 to 25 cm instrument are used for triangulation work. The greater accuracy is achieved with larger theodolite. I already said, right? So the transit vernier theodolite essentially consists of the following: the leveling head. The parts I have explained in the previous video. The same parts will be available here: leveling head, the leveling portion, lower circular plate, upper plate, telescope, vernier scales will be inside this, and here also there will be vernier scales, T or A frame. See here, it look like A. Some manufacturer will give the shape with T shape, and in the other way also, that side also, if you see, the same A will be there, or some manufacturer they will make with T frame. So that frame is called the A frame or T frame, right? So next, plumb bob we have to hold, and the tripod already and in that parts I have mentioned about the clamp screw, and this is the fine adjustment screw for the clamp screw, right? So all the things, this is the lens zooming to read the reading. Here also lens is available to read the reading. This is the bubble tube, horizontal plate, vertical tube, right? So these are the parts you have to remember, right? I have explained how to read the reading, and based on that classification of theodolite, from that which we are predominantly use is transit vernier theodolite, and in that the parts I have explained, right? Thank you, students.